Okay, welcome to this lesson on density. Today's date, if you could put that up in here, please. So I will know the formula to calculate density of regular shaped objects. That's what we're looking at. It fits in here with the first topic from matter. If you haven't got the booklet for this at the moment, you could email your teacher and ask for it. Sources should be available on Firefly. Especially if you're doing this in the summer 2020 during the COVID, haven't issued the booklets yet because it would be out of school. But ideally, you should have the booklet. If you don't have the booklet, just work through as best you can on paper, and we can copy it up when we get our books in. So let's start off with the starter here. Key stage 3 questions for you. What's the difference between mass and weight? What are the SI units for weight? And what are the SI units for mass? Okay, give yourself a bit of thinking time. See if you can get those in your head. What are they? Maybe let's do the units first. Okay, units for weight. Units for weight. Well, the units for weight are, I'll just write them in here. The units for weight are newtons. Okay, that's the units for weight. And units for weight, the SI units are kilograms. Okay, so what is the difference between mass and weight? Well, fundamentally, I would say mass is really how much stuff you are, how many atoms, and measure really how many atoms you are made from, and how big those atoms are, how massive they are. Whereas weight is fundamentally to do with a force that pulls you. You can have a lot of mass. If you're in deep space and there's nothing around you, you'd have no weight, you'd have no force pulling you anywhere. Weight is caused by gravity. So I think the force is called weight, and weight is caused by gravity. And on the Earth, our weight always acts down towards the center of the Earth. Okay, so let's get on to what density is. Well, most of you, I suppose you're familiar with the concept of something being dense. Density is when you have a lot of mass compressed into a small amount of space. If you look at these two diagrams here, you've got the same amount of matter. Well, actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, no, there's more matter. There we go. So we've got more matter in the one on the right. But actually, the matter is more squished in. There's more matter, and that is density. It's the formal way to say is how much mass you get in a certain amount of volume. So that would be the definition of density: mass divided by volume. So this is lower mass. On the left, we have a lower mass, and on the right, which is a higher mass. But the density of this one is higher because the particles are more squished in together. So fundamentally, that is why things like lead and things like that, even though you can't see the spacing of the atoms, there's much more mass in the atoms of lead. They are literally got more stuff inside them, got more protons and neutrons. They're about the same distance spaced apart, so their density is higher. So there's two common units for density. One is the SI unit, so let's maybe do that one first. That's kilograms per meter cubed. So because SI unit is the kilograms is the SI unit for mass, and meters cubed is the SI unit for volume. But another really common one that we do use quite a lot is grams per centimeter cubed. So we'll do a lot of calculations in grams. So you need to be able to work in both of those units. They're not the only units. You can have other units. You could have pounds per inch cubed. That'll be another one. But generally we don't use those. We generally just stick to these ones. Let's have a look. Okay. What's the density formula? Well, to introduce the formulas, I always use this format here, triangle. And the triangle, this one looks like m over v. And this is the symbol for density. It is not p. It is a Greek symbol, and it's pronounced rho. So if I want to do it, the formula is density is mass divided by volume. Or in symbols, I could say rho equals m over v. Okay, so look at that one up. Density, or rho, equals mass divided by volume. Okay, so let's just get those symbols in. So this is the SI units. There we go. So here we go. We've got rho is density, SI unit, kilogram per meter cubed. M is mass, kilograms. V is volume, and that is meters cubed, or M with a 3 superscript. Okay, so the first one I was trying to show you was how to calculate. We cover up rho here, which is density, and we get, see, M over V. M over V. Density equals mass divided by volume. If I want to calculate mass, it's going to be mass equals density times volume. And if I want to calculate a volume, can you see I've got M over rho. Volume equals, and that, look at that, that's nice and wrong, so I'll change that, F2. I'll change that to an X. There you go, like it never happened. Volume equals M over rho. So they're the 3 formulas that really you're just trying to remember this one. You're just trying to remember that one. V equals the triangle, and density is mass over volume, and the others just drop out of that. Okay. So we're going to move on. We're going to do our first equation now. What you really need to do here, though, is make sure that you are actually going to attempt these before we go through. I've got plenty of if you can do all these examples, you'll be absolutely flying. You know all you need to know about how to calculate density. Please take your time now to make sure you attempting the next few questions. You can do it one by one if you want, and then keep on pausing the video. But make sure you're not just watching the examples and completing the booklet. Okay, go ahead, try and do this one now, and then I'll go through it with you. A cuboid has dimensions of 9 centimeters, 3 centimeters, and 12 centimeters. It has a mass of 194.4 grams. Finds the density in grams per centimeters cubed. Okay, so density equals mass divided by volume, or in simples, rho equals mass over volume. What is the mass? Well, it's 194.4. And what's the volume? Well, I'm going to change these centimeters into meters, or else I'm not going to. Oh no, I'm not. I'm going to leave it in centimeters because I want the answer in grams per centimeters cubed. So that's 9 times 3 times 12, which is 194.4 divided by 9 times 3 times 12 is 9 times 3 times 12, 324. Which equals 194.4 divided by 324, which is 0.6. 0.6 grams per centimeter cubed. Now it doesn't ask me to do it in SI units, which is kilograms per meter cubed, but I will just do it here. To get into kilograms per meter cubed, the easiest way is to do density equals mass over volume, but this time change to meters first before you put the numbers in. So it's 194.4 divided by 0.09 times 0.03 times 0.12, and when you do that you'll end up with 194.4 divided by 0.09 times 0.03 times 0.12. And for some of you it might seem strange because we're going to end up with a value of 600,000 kilograms per meter cubed. And some of you might be thinking, well, why is it so much bigger if it's only from centimeters to meters? And that's because we've actually, if you notice, each one of these values underneath here has changed by a factor of 100. So the actual value goes up by a factor of 100 times 3 lots of 100. So it actually goes up by 1,000,000 times. There's actually 1,000,000 centimeter cubed in 1 meter cubed. Okay, second question. A butter block weighs 200 grams. Densities are 8. What is the density? All right, again, we're going to go to So we're going to go in grams per centimeters cubed, because that's what it's asking for. Rho equals m over v. Density equals mass over volume. What's the mass? So it's in grams. It's asked for grams, so we'll leave it in grams. And it's 8 times 5 times 6. 200. Now, sometimes it's actually easy as well. If you want to do it slowly initially, calculate the bottom number first, because otherwise 8 times 5 times 6 is a tendency sometimes for people to do 200 divided by 8, and then when they do times 5 times 6, let's see I'll show you what you would have got if you'd actually done it that way. So if you just put in your calculator 200 divided by 8 times 5 times 6, you might end up with a value of 750, because what you're doing is 200 divided by 8, which will give you 25, and then you multiply that by 5 and 6, so it's 30 times 25, which gives you 750. The actual answer you want is 200 divided by 240, which is 0.83. It's 0.83 recurring, but we'll leave it at 2 sig figs, and that's grams per centimeter cubed. For the clever ones amongst you, that's actually 830,000 kilograms. So 1, 2, 3, 4, yeah, kilograms per meter cubed. You need to multiply that by a million to change it into. A shipping container weighs 100 kilograms, dimensions of 5 by 5 by 8 meters. What's its density? As always, density equals mass divided by volume. 100 divided by 5 times 5 times 8, which is 100, 25 times 8, 25 times 8 equals 200, which is 0.5 kilograms per meter cubed. Okay. A sculpture is made of bronze, density 8.5 centimeters. That should be cubed. Let's show you what that out. It measures 2 centimeters by 2 centimeters by 2 centimeters by 147. Find its mass in kilograms. Okay. Density equals mass over volume. So mass equals density times volume. Now, so its density is grams per centimeter cubed. Now it's given us the density in grams, so we'll leave the volume, we'll calculate volume in centimeters cubed. So it's 8.5, that's 8.5, and the volume is 2 by 2 by 147. So what does that come out as? That comes out as 8.5 times 2 times 2 times 147, which equals 44998 grams. Notice it's grams, isn't it? Because it's centimeter, so it's 8.5 grams per centimeter cubed, which is, I'm just going to call that 5.0 kilograms. Calculate density in kilograms per meter cubed. Should be getting the idea of it now. Density equals mass over volume. This mass is 25, and the volume is 0.1 by 4 by 5. 4 by 5 is 20, so multiplied by 0.1 is goes to 2. 25 over 2, which equals 12.5 kilograms per meter cubed. Lead measures 4 by 5. Lead has a density of 11.5. A rectangular block of lead measures 4 by 5 by 2. Calculate the mass in grams and kilograms. Okay, so density equals mass over volume. Mass equals density times volume, or m equals rho v. So we've got 11.5, and that's grams per centimetre cubed, so we need to calculate the volume in centimetre cubed. 4 times 5 times 2, 4 5s are 20, so that's 40, 11.5 times 40, which equals 460 grams. Divide by 1,000, turn into kilograms, which is 0.46 kilograms. Iris, can you not tell I'm recording here? Iris, can you not tell I'm recording?
Sorry?
Can you not tell I'm recording?
I couldn't tell. I said you were teaching. I couldn't tell you recording. How was I supposed to know?
Well, I couldn't stop to tell you because, you know, it's pretty obvious.
Sorry.
A wooden cube has length 8 centimeters, has a mass of 307.2 grams. Find the density of the cube in grams per centimeters cubed. Density equals mass over volume. The mass is 307.2 grams, and it's a cube, so we want the answer in grams per centimeter cubed, so 8 times 8 times 8, which is 307.2 divided by 64 times 8, which I don't know, so I'm going to calculate it, which is 512 times 307.2. Density is 0.6 grams per centimeter cubed. Okay. So some more tricky ones. I think actually these would probably be more tricky than you'd expect to find in the GCSE. So if you can do these, please take a little pause, see if you can do them yourself before you see the answers, and you know that'll be really helpful. Okay, lead has a density of 11.5 grams per centimeter cubed. A cylindrical block of lead has a radius of 5 centimeters and a height of 3. Find the mass in kilograms. Now this is probably a little bit more difficult than you'd get in a GCSE paper, but so the formula here is 3 centimeters height and 5 centimeters radius, so it doesn't really perfectly match up with what we can see here on this diagram, but this is giving the volume of cylinder to start off with. So here, find the mass. Well, density equals mass over volume. So mass equals density times volume. So the trick to this one is actually calculating the volume, and the volume is pi r squared h. Now, because we're given the density in grams per centimeters cubed, we can carry on working in centimeters here. So it's pi, r is 5, so it's pi r squared times h, which is 3. So it's 25 times 3, which is 75. So 75 times pi, 75 times pi. Now I get that to be 235.6. 235.6, and that's clearly centimeters cubed. So the mass is 11.5 grams per centimeter cubed. Oh, don't really need that up. 11.5 grams per centimeter cubed times 235.6. 235.6 times 11.5, and that comes out at, I would say, rounding up to 3 sig figs, 2710 grams, or 2.71 kilograms in kg. Correct. That's a 3dp. Very good. Okay. Olympic medals have a diameter of 6 centimeters and a thickness of 1 centimeter. Gold has a density of 19 grams per centimeter cubed. Work out the mass of a gold metal to 2dp. Okay. So let's draw my gold medal here. I want to change that. I think really they should be saying in this question to sig figs, not dp. I don't think we need to worry too much about that at the moment, but 2 sig figs is a better description. So the diameter is 6 and the thickness is 1. Okay, so that's the radius is actually 3 there. So again, I think it's another cylinder question as it says there. So the volume is pi r squared h, which is pi. The radius, don't fall over here, the radius is 3, so it's 3 squared. The height is 1, so that's, I'm just going to leave that as in pi for now, so that's 9 pi, so that's approximately 20, a little bit over 27, isn't it? Let's just leave it as pi for now. Density equals mass over volume. Mass equals density times volume. Density is 19 grams per centimeter cubed, and the volume is 9 pi. That's just a number, so at the moment I've just left it as a 9 pi because it's easier instead of calculating it in that. So let's do 19 times 9 times pi. 537 grams. If I want to put that in kilograms, it would be 0.537 kilograms. If I wanted to do it to 2dp, it would be 0.54 kilograms. That's really what that question was asking for. 2dp, 0.54 kilograms. What's the density of concrete block of mass? So this whole block over here is 2,400 kilograms. How much will it weigh? Okay, so there's a little extra tricky bit coming up here, but let's first of all, I'm going to divide my block up into, or even better, I'm going to imagine that block here moving into that segment there, because if you think that segment there is the same as that, you can do it a variety of ways. You can break it up into, fundamentally you want to get the volume of this. If you think that volume there would that would now make one nice big rectangle, wouldn't it, if you just added that there? So that's the volume. You can almost think of that bottom step over here being moved into there. If you can just calculate them all individually, you calculate the volume of that, and then you calculate the volume of that, and you can, but I'm going to do it in one big step. So the volume is equal to 1 times, let's see, that's going to be 0.2, 0.2, that's 0.6, and that is 1, let's see, so it's, and that is 1.2. So it's 1.2 times 0.6. That's really in effect what we've got here is 0.6 by 1. And that is 1.6 is 1.2. So 0.6 times 1 times 1.2 equals 0.72 meters cubed. Density equals mass over volume. Mass equals density times volume. So what's its mass? Its mass is 2,400 times 0.72, which is 1728 1728 kilograms. Have we finished? No, we haven't, because we've been asked to calculate its weight. And weight is m times g. In physics and GCSE we use g as equal to 10, so that becomes 10m. So the weight is 17,280 newtons. Okay, here's some little tricky extension questions here. So find the density of this prism and this trapezium. Okay, in grams per centimeters cubed. So what I'm going to do, first of all, I'm just going to change these all into the same unit. So I'm going to get 4 centimeters, I'm going to get 3 centimeters, and then I've got 11. Now the area of this side here is half base times height. So that's half times 3 times 4. So the area of this side here is half 3 times 4, which is 4 over 2 is 2, so it's 7 centimeters squared. 7 centimeters squared. Okay, and then we've got 11 centimeters down here. So the volume of this block is half times 3 times 4 times 11, which is 77. 11 times 7 is 77 centimeters cubed. Density equals mass over volume, which is 39.6 divided by 77. 39.6. 0.5. Let's go to 3 sig figs. 0.514. And what would the units be? Well, we'll be working in centimeters and grams. So it's grams per centimeter cubed. Okay, we've got a trapezium here. So trapezium is made from cast iron. Its mass is 270, so 35 millimeters at the top. It's 6.5 centimeters, so that is 3.5 centimeters. So really what we can do, this little, if this is a regular, I presume trapeziums are regular, so that must be 1.5 centimeters. That must be 1.5 centimeters. So similar to before, what's going to be this area? I'm going to do like on the concrete steps. I'm going to move that over here. So this actual surface there can be considered now to be a rectangle, but the rectangle is going to be 1.5 centimeters up and 5 centimeters wide. Now that area gives us 1.5 times 5, 7.5 centimeters squared. Multiply by the volume. What's the volume going to be? Well, the volume, look, it goes across here for 5 centimeters. Not very good scale on this trapezium, is it? But that goes 5 centimeters long. So the volume is going to be 7.5 times 5. $37.5. Density equals mass over volume, which is 270.3 divided by the volume, which is 37.5. and that is 7.2. I'm happy with 2 sig figs here. 7.2, and what are we working in? Grams per centimeters.